So 3-4 is taking a function rule, and graphing it. And so this is a little bit more work, but we'll shorten the work up as we move along. So your first function rule that we have here is negative x plus 2y is equal to 6. And you've been given a domain of -4, -2, 0, and 2. So if you're going to graph a function, it is very beneficial to solve that function for y, because remember, x is our input and y is our output. And it's much easier to graph something if we are plugging in x only instead of trying to plug in an x and a y. So I'd rather have it be y equals something rather than this equals 6. So step 1 is to solve for y, since you're given the values of the domain. If we were given the values of the range, then we would have solved for x to make it easier to plug in for that. But usually you're given the domain. So we're going to use our knowledge of solving equations. We're solving for y, so we want to get the term that has y in it on one side by itself. So to get rid of minus x, we're going to add x to both sides. So the x cancels on the left, and we get 2y is equal to, and I'd like you to get in the habit of trying to put it into the form of y equals mx plus b if at all possible. Not all of these functions are linear, but we're going to put the x term first. So we get x and then plus 6. Then to solve for y, we're going to divide this side by 2 and divide this whole side by 2. And the 2 cancels, and we get y equals, you can have y equals this exactly as you see it and use that in your table for your input-output table. Or I need you to understand that we cannot just cancel the 2 into the 6 because it doesn't cancel into the x. So unless this denominator cancels into everything in the numerator, you cannot cancel it out. So we're going to split this up. You've got to divide each item in the numerator by that denominator. So the true slope-intercept form of this would be y equals, and then to figure out what the coefficient is in front of x, we're going to remove x from that fraction, just take it out. So removing x from the fraction and just putting here off to the side. And if I do that, take the x away, there's actually 1 left in the numerator over 2. So the coefficient of x becomes 1/2. 1/2 of x is the same as x divided by 2. And then we can take 6 divided by 2, which is a plus 3. So this is the function rule that you're actually seeing in the table down here. So then we're going to use an input-output table to find the values for y, now that we've solved the rule for y. So these are the domain values that we were given. We're just going to plug them in here and come out with our y values. So I'm going to do y equals 1/2. Wherever I see an x, I'm using parentheses. And then I'm going to input my domain, which is changing each time, in for x. Okay, so for the first one, 1/2 of -4 is -2 plus 3, which gives us a value of 1. For the second one, 1/2 of -2 is -1 plus 3, which gives us a value of 2. For the next one, 1/2 of 0 is 0 plus 3, which gives us a value of 3. And then 1/2 of 2 is 1 plus 3, gives us a value of 4. So the ordered pairs that we get is the x value combined with the y value. So the ordered pair always has parentheses. So we've got -4, +1, -2, +2, 0, 3, and 2, 4. So these are our inputs and these are their outputs. And then now we can go ahead and plot or graph those ordered pairs. So we're going to go on to the next slide to do that. So here we're going to graph -4, 1. So from the origin, you're going to go left 4 for your x value of -4 and up 1 for your y value of 1, and you're going to plot a point. And then we had an x value of -2, which gave us a y value of 2. So we're going to plot that point. Then we had an x value of 0 and a y value of 3, and we're going to plot that point. So far you see that they're making a nice straight line. And our last value was a value of 2, which gave us an output of 4. So we're going to plot that point. And so I do not have, well, maybe I do have the ability. Hang on, let me see if I have the ability to draw a line, which I do. Well, maybe I'll do this line. Okay. So I'm going to connect, oh, look at that. It's not where I wanted that line. All right, so let me take that away. I don't like that. Okay, let's try that again. So I want to draw a nice straight line. Does not, okay, well, it wants to start from there, so I'll just hand draw it. And it's going to be crooked. So this is our line. You should be using a ruler. Clearly, I can't. But that is the line that represents the whole function. These points that we plotted here are just parts of the domain and range, but there is an infinite number of domains and range that will make that function rule true. So for example 2, this is our function rule. It's just the absolute value of x, and this is our domain. So we're going to plug into here, f of x is equal to the absolute value of something. And then we're going to plug in our domain values of -2, -1, 0, 1, and 2. So the absolute value is always positive because it is the distance that a number is from 0. So the absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1, so you see a repeated value. The absolute value of 2 is 2. So we're going to write our ordered pairs. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Then we're going to graph those ordered pairs down below. So -2, 2. Oops, totally plotted that on the wrong spot. All right, let's try it again. How about there? And then -1, 1. 0, 0 is at the origin. And then 1, 1. And then 2, 2. And then if I connect those, it looks like a V. So what you will find is the absolute value bounces. And because y, our output, can only be positive, you see that the range is from 0 to positive infinity, whatever positive value you can think of. Whereas the x value can be negative, positive, or 0. It can be any number you can possibly think of. So the x is unrestricted, the domain is unrestricted, the range is restricted to only positive values. All right, so then we're going to graph each of these functions. And when you graph a function, you're not going to be given the table of values as we had in the other ones. So you're just given this function. You've got to make sure that the function's solved for y, which this one is, and then you are going to have to choose several values of x to generate some ordered pairs. We always suggest you choose some negative, 0, and some positive. So that's what you see us doing here in step 1. So we've already solved the function for y. We're just going to plug in some values, and we chose these values because there's some negative, 0, and some positive. You want enough ordered pairs to get a good shape to your graph. So I'm going to just plug these into my input-output table using parentheses for my x. Alright, so I'm going to input my x values. So far I haven't done any math. Just doing the prep work. Okay, so 2 times negative 3 is negative 6 plus 1, which gives me negative 5. 2 times negative 2 is negative 4 plus 1, which gives me negative 3. 2 times negative 1 is negative 2 plus 1 gives me negative 1. 2 times 0 is 0 plus 1 gives me positive 1. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. And finally, 2 times 3 is 6 plus 1 is 7. Now this particular rule, that's actually 7, this particular rule has x increasing by 1 each time, and then you can see the pattern that y is increasing by 2 each time. So that kind of helps you determine, did I make a math error? And if you go back and look at the rule, remember we talked about if there's a constant difference in y, that's going to show up in the function rule. Notice what is x being multiplied by? 2. That's that common difference in y. So it correlates. Then we're going to write our ordered pairs. Our ordered pairs are negative 3, negative 5, negative 2, negative 3, negative 1, negative 1, 0, 1, 1, 3, 2, 5, and 3, 7. So then you're going to graph. Oops, next slide. So we're going to plot enough points. So our first set of points was negative 3, negative 5, which is going to be down here. We're going to plot all of them. And then our next ordered pair was negative 2, negative 3. Then we had negative 1, negative 1. Then we had 0, 1. Then we had 1, 1, 3. And finally, we had 2, 5. And if we were to connect those, with a perfectly straight line, there is the graph of that function rule. I think that's it on that slide. Yep. Your turn. Now you graph the function y equals x squared. This is not going to be a straight line, just to warn you. So I will get you started. So the rule is already solved for y. So you just have to put in here y equals something squared. And then you're going to put in your x value, which in the first case is negative 3. And remember, this means negative 3 times negative 3, which is a positive 9. So stop the video, you finish the rest of the input-output table and write out your ordered pairs, and then start the video up again. Okay, so I'm going to put in -2, -1, 0, 1, 2, and 3. So -2 squared is -2 times -2, which is +4. -1 squared is -1 times -1, which is +1. 0 squared is 0 times 0, which is 0. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. So you see some repeated values. And then 3 squared is 3 times 3, which is 9. So your ordered pairs are -3, +9, -2, +4, -1, +1, 0, 0, 1, 1, 2, 4, and 3, 9. I believe our graph is on the next slide. Yes. So here we go. So we're going to graph those ordered pairs. So we started with -3. And if we go to -3, it'd be between -2 and -4. And we're going to go up to between 8 and 10 because we had to have our graph go by 2's. So that means that we've got a point right here. And then our next ordered pair was -2, +4. So we're going to plot that here. And then our next ordered pair was at origin. No, we did 1, didn't we? So -1, +1 would be right here. And then we had 0, 0. And then we had +1, +1, which would be here. +2, +4. And then +3, +9. So this is the graph of a quadratic, which is called a parabola. Then we can use graphs to help us find values. So this one says, use a graph of this function to find the value of f of x when x is 6. Now technically we could just plug it in. So we could take the function and take f of 6, which is what we were doing before. We would have 1/3 times, and I'm going to put this as 6 over 1 just so you could see how we take 1/3 of 6 plus 2. So 1/3 of 6 is 2 because 3 divides into 6 twice. So you end up with 2 plus 2, which is 4. So f of 6 is equal to 4. So we should be looking for the ordered pair 6, 4. So if you look at this graph, if you go to the right 6 and up 4, here is that point on the graph. Well, instead of plugging into the function as we did here, we could have very simply just gone to the right to an x value of 6, and from there gone straight up to the graph until we hit it, and then gone straight over to the y-axis, and there's our solution 4. So we didn't have to go through the algebra and do all of this. We could have just seen it from the graph. So the function y equals 2.5x describes how many millimeters sea level y rises in x years. So they've told us that this is years right here, because this is our x-axis, and that sea level rises, so this is sea level here because this is our y-axis. You are to graph the function and use the graph to estimate how many millimeters sea level will rise in 3.5 years. We could plug 3.5 into 2.5 or 2.5 times x, or we could just graph. So if we set up a table of values, and it would not be realistic to have a negative value for x because we won't have negative years. So we could have 0 in 0 years, although that's probably not accurate either, but we'll go ahead and put 0 in, 1 year, 2, 3, and 4 because 4 goes past our 3.5. I'm going to plug those values in and plot those points. So I've got 2.5 times something. We're going to plug in our x values of 0, 1, 2, 3, and 4. 2.5 times 0 is 0. 2.5 times 1 is 2.5. 2.5 times 2 is 5. 2.5 times 3 is 7.5. And 2.5 times 4 is 10. So I'm going to plot these ordered pairs. So when x is 0, y is 0. So that would be right here. When x is 1, y is 2.5, which would be right about here. When x is 2, y is 5, which puts us here. When x is 3, y is 7.5, which would be here. And when x is 4, y is 10. So we have a straight line that represents that function. And so we want to know how many millimeters sea level will rise in 3.5 years. Well, years is on this axis, so we're going to go over to 3.5. And we're going to draw a line, or a little dotted line, dashed line, up until we hit the graph. And we're going to go over to here. And we would estimate that as probably, most of you would estimate it as 8.5 because it's somewhere in between 8 and 9. Well, let's see what it actually is by actually plugging it into the function. So if f of 3.5, we're going to plug that into the function rule of 2.5x. So that's equal to 2.5 times 3.5. Let me get my handy dandy calculator. That I don't want to do in my head. So that's 8.75. So f of 3.5 was 8.75. So we would have guessed based upon our graph that was 8.5 when in reality it's 8.75. So finding or estimating, and bear in mind this is an estimate because clearly we didn't get the exact answer by using the graph because it was 8.75. But we did get close enough, and so just so long as you know that using the graph is an estimate, it's not an exact answer, whereas using the function rule will give us an exact answer.